Let us look at this polynomial, or these polynomials. We have f of x equals x squared. F of x is equal to 3x squared. F of x is equal to 3x squared plus 5. Now, how do they behave? What is the limit of these polynomials as x tend to infinity? So, we want to find the limit of all of them as x tend to infinity. Let's look at the graph. Y equal x squared, or f of x equal x squared, x to the power of 2. Okay, so as x tends to infinity, the value of the graph also tends to infinity. Let's look at another one. What was it again? And you could see that as x gets larger, the value of f of x will get larger too, but we want to look at the curve and the general behavior. 3x squared, 3x squared. So, in this case, we have another graph. Or, before I plot that graph, let me fix this one up. Let me make it very thick. And let the color, yes, remain black. 3x squared. 3x to the power of 2. Okay, this is yet another one. Let me make this thicker. And use a different color. Say red, or let's look pinkish. Okay, the third one is 3x squared plus 5. So, if we have 3x to the power of 2 plus 5, we get this. Let's make this thick. And change the color to blue. Alright. Now you have similar behaviors. Alright. Here, both, all three, as x tends to infinity, all three shoot up rapidly to infinity as well. There is no horizontal asymptote, meaning there is no horizontal, well, that's not very horizontal. There's no horizontal line that they're approaching, that they're getting closer and closer to, right? There's also no vertical line that they're getting closer and closer to, but never touch it. There's no horizontal line that they're getting closer and closer to, but never touch. There's no vertical line that they're getting closer and closer to, but never touch. So they have no horizontal nor vertical asymptote. Now, what happens if we make a minor change? Instead of square, we use cube. We're going to find x cubed, the limit of x cubed, the limit of 3x cubed, the limit of 3x cubed plus 5. How do they behave generally? Now, you can see that as you increase the values of x cubed gets very large. Alright? Now, if you change this to x cubed, x to the power of 3, this is what you have happen. What about 3x to the power of 3? You see, these two are behaving the same way. They are shooting up to infinity on the positive side, shooting down to infinity on the negative side. What about this one? 3x cubed plus 5. Same thing. Alright. So whatever number you multiply the x by, or whatever number you add, doesn't change the general behavior of the curve. Now, let's make a change to the third one. Suppose it was 3x squared plus 2x plus 5. What will happen? 3x squared plus 2x plus 5. Here, as x tends to infinity, you can see that f of x is also tending to infinity. Alright? And you can see that as x tends to or approaches 0, f of x is approaching 3 by 0 cube, which is 0, plus 2 by 0, which is 0, plus 5, approaching 5. But let's look at the graph. As x tends to infinity and as x tends to 0. 3x cubed plus 2x plus 5. So, this is the blue one. 3x cubed plus 2x plus 5. Okay. So you have the same general behavior. Alright? And you can see that when x is 0, f of x is 5. But as you increase x towards infinity, on the right, the graph shoots up to positive infinity. On the left, as you move x towards negative infinity, the graph shoots down towards negative infinity. Alright? So, whatever number you multiply x cubed by, whatever number you add to it, add to the end of the graph, you have the same general behavior. Now, let's look at one more adjustment to this. First of all, let's forget about these up here, and we have 3x cubed plus, say, 2x squared plus 4x plus 5. Which one will it behave like? Is it the x squared? Remember, the x squared was like this, the x cubed was like this, the shape. We have an x cubed and an x squared. Let's plot this graph and see how it will behave. 3x cubed, 2x squared. 3x, first of all, let's erase these two. I'm not going to use these two right now. Let's get rid of this one and this one. We want to have a new graph and see how it will behave compared to this one. Remember, this one was 3x cubed plus 2x plus 5. Let's put in our new graph. 3x cubed plus 2x squared. We have 3x to the power of 3 plus 2x to the power of 2 plus 4x plus 5 plus 4x plus 5 plus 4x plus 5. Let me make this new graph thick. The curve of the new graph thicker and change the color to some greenish color. Oh, you see, it's the same behavior. It's not behaving like x squared, it's behaving like x cubed. Right? Now the thing is, the highest power of x here is 3x cubed, and it is called the leading term. The whole graph will behave in the same general shape as that of the leading term. Alright? You see, in these cases, you have 3x cubed. This behaves like 3x cubed, is just that the general shape of the curve is just like 3x cubed. The general shape of the curve for this is just like 3x cubed. Because the cube here is the highest power of x. It's not going to behave like x squared. It's behave like x cubed, even though there's an x squared in it. Alright? So, we see here that when it comes to the polynomial that takes this form, where you raise to a positive power of x to a positive number, what you have is no horizontal asymptote, no vertical asymptote. Let's be reminded about what happened when you raise a number to a negative power, to the negative 3. The same as 1 over x to the positive 3. So, if we change this graph to 1 divided by x raised to the power of 3, what we get is this. So now you have a horizontal asymptote, you have a vertical asymptote. Why? Because you can see that as you approach 0, as you extend to 0, what you have is 1 divided by 0, which is an infinitely large value. So that's why when x is near to 0, the value of the graph is extremely high, very high, or very low on the left. And as x tends to infinity, 1 over x cubed comes 1 over infinitely large number cubed, which is 1 over an infinitely large number, which is 0. And here, as x gets higher and higher, this curve, it doesn't touch 0 enough. It's getting closer and closer to 0, but never touches it. We can see if we zoom in, the curve is not going onto the 0 line. It gets closer and closer to it, but will never reach it. So you have both vertical and horizontal asymptote for a negative power. Number x raised to the power of a negative number. Alright? So I will see you in the next video.